In Texas, they're going hog wild over wild hogs. The feral animals are causing hundreds of millions of dollars of damage to crops across the state.
3 hours past midnight, Avoyelles.
Imagine standing in the middle of a Louisiana rice field long after midnight. The air is thick with humidity. The only sounds coming from insects hidden in the grass and the occasional splash from a nearby bayou. To the naked eye, the landscape appears completely empty. But hundreds of feet above, a thermal drone paints a very different picture. Every living creature glows against the darkness. Deer appear as bright white figures drifting along tree lines. Raccoons dart through drainage ditches. And in the center of one flooded field, a group of massive feral hogs moves slowly through the mud, rooting for food. For wildlife control teams, this is exactly what they expect to see. What they don't expect is a lone heat signature sitting silently at the edge of the woods, watching. At first, nothing seems unusual. Wild hogs often pause while feeding, and thermal cameras can sometimes blur nearby animals together. But this figure never joins the herd. Instead, it waits with remarkable patience. Every few moments it inches forward, freezes, and waits again. The movement is deliberate, almost calculated. Then, without warning, the glowing shape explodes into motion. Before the drone operator can zoom in, it disappears beneath the trees, leaving behind nothing but confused silence on the radio. The hogs scatter briefly before returning to feed, as though nothing had happened. For the drone crew, the moment lasts only seconds, but it raises a question none of them expected to ask. If it wasn't another hog, what exactly had they just watched? To understand why that question matters, you first have to understand the scale of Louisiana's feral hog problem. Few invasive animals have spread across North America as successfully as wild pigs. Descended from domestic swine brought by European explorers centuries ago, and later mixed with Eurasian wild boar introduced for hunting, today's feral hogs possess the toughness of both ancestors. They adapt to forests, marshes, farmland, river bottoms, and even suburban edges with remarkable ease. They are intelligent, highly social, and capable of learning from failed attempts to trap or hunt them. Their greatest advantage, however, is reproduction. A healthy sow can produce multiple litters in a relatively short period, allowing local populations to recover quickly even after aggressive control efforts. Wildlife managers often estimate that removing only a portion of the population accomplishes little because the remaining animals reproduce fast enough to replace their losses. In many regions, the population continues growing despite years of intensive management. For Louisiana farmers, the consequences are impossible to ignore. Entire fields of rice, corn, soybeans, and sugarcane can be devastated in a single night. Rooting hogs overturn topsoil while searching for roots, insects, and bulbs, destroying carefully planted crops and leaving deep ruts that damage expensive farming equipment. Levees weaken under repeated digging. Wetlands become churned into muddy wallows. Streams and ponds are contaminated, while native wildlife must compete with an invasive species that consumes almost anything it finds. The financial cost is enormous. Across the United States, feral hogs cause billions of dollars in agricultural and environmental damage every year, making them one of the country's most destructive invasive mammals. Louisiana alone supports hundreds of thousands of these animals, spread across nearly every parish. Traditional hunting helps, but it rarely keeps pace with the animal's extraordinary reproductive rate. Traps remove entire family groups, yet new sounders often move into the same territory within weeks. As the problem grew, wildlife professionals realized they needed better tools. Night offered the greatest opportunity because feral hogs become most active after sunset, when cooler temperatures encourage feeding. But darkness also hides them from conventional patrols. Advances in thermal imaging technology changed that completely. Cameras originally developed for military and search and rescue operations could now detect the body heat of animals moving through complete darkness. Mounted beneath drones, these systems gave operators an aerial view impossible to achieve from the ground. Flying carefully planned routes over farmland after midnight, drone crews could locate entire sounders within minutes and direct ground teams with remarkable precision. Operations became faster, safer, and far more effective than relying solely on spotlights or night vision scopes. For many farmers, thermal drones represented the first technology capable of matching the hog's nocturnal lifestyle. No one involved in those early operations expected the drones to reveal anything beyond the invasive animals they had been sent to eliminate. Yet, as operators spent hundreds of hours scanning Louisiana's fields and forests, some began noticing heat signatures that refused to fit familiar patterns. They did not move like deer. They did not behave like coyotes. And they certainly were not feral hogs. At first, most dismissed the strange sightings as poor image quality or equipment limitations. Then one encounter lasted just long enough to make ignoring it impossible. The first unexplained sighting could have been dismissed as a coincidence. Thermal cameras are powerful tools, but they are not perfect. They record heat rather than visible detail, reducing every warm-bodied animal to glowing shapes against a cooler background. At a few hundred feet above the ground, dense vegetation, humidity, and uneven terrain can blur outlines enough that even experienced operators occasionally hesitate before identifying a target. A deer partially hidden by brush can resemble a large dog. A coyote running through tall grass may appear almost identical to a young hog. Most unusual sightings are eventually explained by better angles or clearer footage. But this one kept returning. Over the following weeks, operators flying nighttime missions across agricultural land noticed the same solitary heat signature appearing near different groups of feral hogs. It never traveled with the sounders. It never wandered randomly through fields searching for food. Instead, it remained hidden along the boundary where dense woodland met open farmland, as though using the tree line for cover. It would remain motionless for long periods before slowly advancing a few yards at a time. Then it would freeze again. The pattern repeated often enough that experienced drone pilots began paying closer attention. They had watched thousands of hogs from the air. They understood how family groups behaved, how individuals reacted to danger, and how animals scattered when startled. This mysterious visitor behaved differently. It showed patience instead of panic, precision instead of curiosity. One operator later described the movements as almost mechanical. Every advance appeared intentional. There were no wasted steps, no sudden changes in direction. Whatever the animal was, it seemed less interested in wandering the landscape than in waiting for exactly the right moment. Wildlife biologists recognize this style of movement immediately. Many predators rely not on endurance, but on stealth. Rather than chasing prey across long distances, they minimize every unnecessary movement until they are close enough for a rapid attack. Remaining unnoticed is often more important than speed itself. Energy saved during the approach becomes energy available during the final sprint. The thermal footage could not identify the animal with certainty, but its hunting strategy narrowed the possibilities considerably. Louisiana supports several predators capable of hunting medium-sized mammals. Coyotes are widespread and highly adaptable, yet they usually travel with quick, restless movements while constantly changing direction to investigate scents. Bobcats are secretive ambush hunters, but are significantly smaller than the glowing figure repeatedly appearing near adult feral hogs. Black bears occasionally consume piglets, particularly during periods when natural foods are scarce, but adult bears move with a completely different body profile and are rarely observed conducting prolonged stalks across open agricultural fields. None of those species perfectly matched what the drone operators continued to observe. Curiosity gradually replaced skepticism. Rather than dismissing the sightings, operators began recording every unusual encounter. Flight logs were compared between neighboring properties. Maps were marked with locations, times, and weather conditions. Slowly, a pattern emerged. The mysterious heat signature wasn't appearing randomly. Most sightings occurred within a connected landscape of forests, wetlands, drainage corridors, and agricultural fields that provided both cover and abundant prey. If the observations represented the same individual, it was covering remarkable distances while remaining almost entirely invisible to people on the ground. The drone crews realized they needed evidence that thermal cameras alone could not provide. Heat signatures reveal movement, but they cannot show fur color, facial features, tail length, or other characteristics necessary for positive identification. The only way to answer the question was with conventional wildlife monitoring. Trail cameras were installed along game trails, fence crossings, and wooded corridors, where the thermal footage repeatedly suggested the animal entered or exited the fields. Unlike drones, these cameras could capture high-resolution infrared photographs whenever movement triggered their sensors. The challenge was deciding exactly where to place them. A single camera positioned only a few yards away from the correct route might record nothing for weeks. Days passed with little success. Memory cards filled with images of deer browsing before dawn, raccoons investigating fallen logs, armadillos shuffling through leaves, and the occasional coyote slipping silently across the frame. Every ordinary photograph increased the mystery because none explained the strange behavior witnessed from the air. Then field crews began noticing something else. Several hog carcasses, discovered near wooded areas, looked unusual. They were not scattered by scavengers or left exposed in open ground. Instead, some had been dragged into thick vegetation, partially covered with leaves, branches, and forest debris. Wildlife biologists refer to this behavior as caching, a strategy used by certain predators to hide a kill from scavengers before returning to feed again later. Caching is common among large cats in many parts of the world. It is not considered typical behavior for coyotes, feral dogs, or most other predators regularly found in Louisiana. Individually, none of these observations proved anything. A blurred thermal image could be misidentified. Drag marks might have more than one explanation. Trail cameras had yet to capture the animal responsible. But together, the clues were beginning to point in a direction few people expected. If the evidence continued to build, Louisiana's nighttime drone operations might reveal not just another predator, but one that many residents believed had disappeared from the state generations ago. When the trail cameras were finally checked after another long week, most of the memory cards looked exactly as expected. Thousands of photographs showed ordinary nighttime visitors. White-tailed deer feeding at the edge of soybean fields. Raccoons investigating fallen logs. Armadillos rooting through loose soil. Coyotes passing quickly through the frame without lingering. For a moment, it seemed the mysterious heat signature would remain exactly that, a mystery. Then one camera, mounted low beside a narrow game trail leading from dense woodland toward an open rice field, captured something different. The sequence began with an empty frame illuminated only by the infrared flash. Nearly 30 seconds passed before movement appeared at the bottom corner of the image. At first, only the outline of a low body could be seen sliding silently through the grass. Unlike a coyote, which normally carries its head high while constantly scanning its surroundings, this animal stayed remarkably close to the ground. Every movement was controlled. Every step appeared deliberate. The camera continued recording as the animal paused behind a patch of brush. Less than 40 yards away, several feral hogs remained completely unaware of its presence. They continued rooting through soft soil, occasionally nudging one another as they searched for food. The distance between hunter and prey slowly disappeared. Then everything changed in an instant. The quiet approach gave way to an explosive burst of speed. The animal launched itself across the remaining ground with astonishing acceleration, covering the final distance before the nearest hog had time to react. The camera captured only fragments of the attack before both animals disappeared beyond the edge of the frame. Dust rose into the infrared light. Branches shook violently. Seconds later, silence returned. Although the struggle itself occurred outside the camera's view, the brief images recorded beforehand provided the detail investigators had been searching for. The animal possessed a long, muscular body supported by powerful hind legs. Its head appeared relatively small compared with its shoulders, while an unusually long tail extended behind it, remaining low throughout the approach. Even under infrared illumination, its proportions differed dramatically from those of a coyote, bobcat, or domestic dog. For wildlife experts reviewing the footage, Those physical characteristics pointed toward a single conclusion. The predator appeared to be a mountain lion. Known scientifically as puma concolor, the mountain lion carries more common names than almost any other large mammal in the Americas. Depending on the region, it may be called a cougar, puma, catamount, panther, painter, or simply lion. Despite the different names, they all refer to the same species, a solitary apex predator whose historical range once stretched farther than any other wild land mammal in the Western Hemisphere. Centuries ago, mountain lions occupied nearly every major habitat in North America. From dense eastern forests and Appalachian mountains to western deserts, tropical regions, and the Canadian wilderness, they adapted to an extraordinary variety of environments. But as European settlement expanded during the 18th and 19th centuries, large predators increasingly came into conflict with livestock production and growing human populations. Government bounty programs encouraged hunters to eliminate mountain lions across much of the eastern United States. Habitat disappeared beneath expanding farms and towns. Deer populations, their primary prey, declined sharply due to overhunting. By the early 20th century, mountain lions had vanished from nearly all states east of the Mississippi River, surviving mainly in isolated western landscapes and, eventually, within the small endangered Florida panther population. For generations afterward, reports of large cats in states like Louisiana were generally treated with skepticism. Wildlife agencies occasionally investigated tracks, photographs, or eyewitness accounts, but confirmed evidence remained exceptionally rare. Most reports ultimately proved to involve bobcats, escaped exotic animals, unusually large domestic cats, or simple misidentifications under poor lighting conditions. That history explains why the drone footage attracted such attention. If the trail camera had indeed captured a mountain lion hunting a feral hog in Louisiana, it did not necessarily mean the species had re-established itself there. Biologists understand that young male mountain lions are capable of dispersing hundreds, and sometimes more than 1,000 miles while searching for unoccupied territory. These remarkable journeys occasionally carry them far beyond the boundaries shown on traditional wildlife distribution maps. The real question was no longer whether a mountain lion could reach Louisiana. The question was whether this wandering predator represented an isolated traveler, or the first sign of a much larger ecological story unfolding quietly across the American South. The discovery immediately raised a question that extended far beyond a single predator caught on camera. If a mountain lion had reached Louisiana, how had it managed to travel so far without attracting widespread attention? The answer lies in one of the species' most remarkable biological traits: its ability to disperse across extraordinary distances. Unlike wolves, which live in packs and defend established territories together, mountain lions lead almost entirely solitary lives. Young cubs remain with their mothers for roughly 2 years, learning how to stalk prey, avoid danger, and survive on their own. But eventually comes a moment when they must leave. Adult males will not tolerate another mature male within their territory, forcing younger animals to begin a journey into unfamiliar landscapes where they must establish a home range of their own. These dispersal journeys can be astonishing. One of the best documented examples occurred in 2011, when a male mountain lion struck by a vehicle in Connecticut was genetically traced back to the Black Hills of South Dakota. The animal had traveled more than 1,500 miles across farmland, rivers, highways, and densely populated regions before reaching the East Coast. It remains one of the longest confirmed overland movements ever recorded for a North American land mammal. Similar, though shorter, dispersal events have been documented in Missouri, Arkansas, Nebraska, Tennessee, Iowa, and several other states far outside established breeding populations. These records have changed the way wildlife scientists think about species distribution. Maps showing where mountain lions live often represent breeding populations rather than every place an individual animal may travel. A wandering young male can spend months, or even years, crossing landscapes where no permanent population exists. Unless it leaves behind unmistakable evidence, such as DNA, photographs, or verified tracks, it may pass through unnoticed. Louisiana presents an especially interesting case. While the state does not have a confirmed breeding population of mountain lions, it offers several ingredients that could attract a dispersing predator. Vast wetlands, hardwood forests, river corridors, and abundant prey create pockets of habitat capable of supporting a large carnivore, at least temporarily. White-tailed deer populations remain healthy throughout much of the region, and the explosion of feral hogs has unintentionally added another large prey source that did not exist in such numbers centuries ago. From an ecological perspective, the landscape provides opportunity. For decades, wildlife managers viewed feral hogs almost exclusively as a management problem. They damage crops, compete with native wildlife, spread disease, and reproduce at extraordinary rates. But predators view the same animals very differently. To a hungry mountain lion, an adult hog represents a challenging but nutritious meal capable of sustaining it for several days. Although hogs can defend themselves aggressively with powerful tusks and surprising speed, experienced predators often target isolated individuals or animals caught away from the protection of the larger sounder. This relationship has been documented in parts of the western and southern United States where mountain lions and feral hogs overlap. Studies examining cougar diets have found that while deer remain their primary prey, wild pigs are also taken where they are abundant. Researchers emphasize, however, that predation alone does not eliminate invasive hog populations. The reproductive capacity of feral swine is simply too great for a relatively low-density predator to suppress entirely. Even so, predators influence ecosystems in ways that extend beyond the animals they kill. Ecologists use the term landscape of fear to describe how prey species alter their behavior when they know predators are present. Deer spend less time feeding in exposed areas. Elk avoid valleys where wolves frequently hunt. Wild pigs may shift their movement patterns, spend less time in open fields, or become more cautious while foraging. These behavioral changes reduce grazing pressure, limit crop damage in some areas, and allow vegetation to recover in places that predators regularly patrol. This concept became widely known after the restoration of gray wolves to Yellowstone National Park. As wolves returned, elk changed where and when they fed, allowing young willow and aspen trees to recover along riverbanks. Those recovering forests benefited birds, beavers, insects, and countless other species. While every ecosystem is different, the lesson remains the same. Apex predators shape landscapes not only through predation, but through the constant possibility of predation. Whether the wandering mountain lion in Louisiana remained for weeks or only a few days, its presence carried a reminder that ecosystems are rarely as static as maps suggest. Animals move. Habitats change. Opportunities appear where none existed before. And sometimes, while searching for one environmental problem, researchers unexpectedly uncover evidence that another piece of nature has quietly returned. By the time the footage had been reviewed by experienced wildlife observers, the conversation had shifted. The mystery was no longer whether an unusual predator had been captured on camera. Instead, researchers began asking what the discovery could teach them about the changing ecology of the American South. Ironically, none of the technology involved had been designed for wildlife research. Thermal drones were purchased to solve a costly agricultural problem, not to survey rare predators. Their mission was simple: locate feral hogs quickly, direct ground crews efficiently, and reduce the damage these invasive animals cause to farms and wetlands. Yet every flight collected far more information than anyone originally expected. Unlike trail cameras, which monitor only a single location, drones can survey hundreds of acres during a single mission. They reveal how animals move across entire landscapes rather than how they behave at one narrow crossing. Deer leaving forest cover before dawn, black bears traveling between feeding areas, alligators crossing marshes at night, and even elusive bobcats become visible in ways that traditional field surveys rarely capture. Every mission creates an unexpected record of wildlife activity. Conservation scientists have begun recognizing the value of this accidental database. Across the United States, researchers increasingly collaborate with landowners, wildlife control operators, and drone pilots who spend far more nights in remote habitats than most scientific field teams ever could. Every unusual sighting, every unexplained movement pattern, and every unexpected predator captured on thermal imagery has the potential to improve understanding of species distribution and behavior. The mountain lion footage from Louisiana illustrates this perfectly. A single observation cannot confirm that the species has permanently returned to the state. Wildlife agencies require repeated evidence, verified tracks, genetic samples, photographs of multiple individuals, or proof of reproduction before recognizing an established population. Scientific standards remain deliberately strict because extraordinary claims require equally strong evidence. Even so, isolated dispersing mountain lions are becoming increasingly difficult to dismiss. Similar confirmed records continue appearing farther east than many experts once believed possible. Each verified observation suggests that suitable habitat still exists in places long assumed empty of large predators. Rivers, forests, wetlands, and protected public lands create natural travel corridors that wandering animals continue to explore, often without human knowledge. The implications extend beyond mountain lions alone. Every ecosystem depends on relationships between predators and prey that have developed over thousands of years. When apex predators disappear, prey populations often expand unchecked. Vegetation changes and ecological balance shifts in ways that ripple throughout the food web. Restoring those predators is rarely simple, but documenting their natural movements helps scientists understand how ecosystems may recover over time. At the same time, experts caution against unrealistic expectations. One wandering cougar cannot solve Louisiana's feral hog crisis. The state's invasive pig population is simply too large and too productive for any single predator to control. Effective management will continue requiring coordinated trapping, aerial removal, habitat monitoring, and cooperation between private landowners and wildlife agencies. Predators are part of the solution, but never the entire solution. Perhaps the greatest lesson comes from the technology itself. Humans created thermal drones to manage a problem we introduced into the landscape. Yet those same machines unexpectedly reminded us that nature continues operating beyond our assumptions. While people focused on invasive hogs destroying crops, a native predator had been quietly moving through the same forests, largely unnoticed. It had not returned because someone released it. It had simply followed instinct, crossing rivers, highways, forests, and farmland in search of opportunity. Sometimes the most important scientific discoveries happen not because researchers find exactly what they were looking for, but because they remain curious enough to investigate something they never expected to see. When wildlife officials examined reports from Louisiana, one fact became impossible to ignore. Mountain lions once roamed almost every part of North America. Before European settlement, they lived from the forests of Canada to the southern tip of South America. They occupied more territory than almost any other land mammal in the Western Hemisphere. But during the 19th and early 20th centuries, relentless hunting, habitat destruction, and government bounty programs erased them from most of the eastern United States. By the time modern wildlife agencies were established, breeding populations remained only in parts of the West, while the endangered Florida panther survived as a small, isolated population. To most people in Louisiana, a mountain lion belonged in history books, not in the woods beyond their farms. Yet mountain lions have one remarkable characteristic that continually surprises biologists. Young males travel extraordinary distances in search of new territory. Once they reach maturity, dominant